Okay, we're now in the six weeks. And so since we're in the six weeks, it comes a time for me to look into the Algebra 2 book and say, what are some things that we absolutely have to cover before we finish up the school year? And so that's why I ended up in Chapter 6. Chapter 6 is on quadratic equations. And so we're going to cover quadratic equations. I want to do a couple of preliminary things here as we start today. One is I want to get my book up here, and just because I'm afraid I'll forget to do this. I'm afraid I'll tell you what problems to do, but not show them to you. So again, when I do this, I can't really see that good what's coming through, but I think if I hold it still, then you can get it all and get a picture of that. Hopefully that's been apparently working out pretty good. All right, the second thing I want to do is I want to get you to download an app on your phones. Okay, so some of you have graphing calculators that you use and all that. That's great. If we've never required it, one of the reasons I don't require it anymore is because they're free on the phone. This is an amazing graphing calculator application that I found a long time ago that I keep on my phone, and I want to recommend it to you and get everybody to download it now. So I'm in the App Store now, and I hit the little, this little search deal right here, and I type in EduCalc, E-D-U-C-A-L-C, EduCalc. And what comes up is this little blue thing right here with a little curve on it. All right, and it says open on mine because I already have it right there. So you download that for free, and then you're going to have this app. And when you let's see, so that's what the calculator looks like. And so the app is going to look like this on your phone. Okay, same little blue thing with a little curve going down like that, right? And when you type it in, when you open it, you're going to have this. So I want y'all to download that now, and I'm going to start on the lesson, and I'm going to come back to this in a minute and show you how you're going to use this calculator, because the things I'm going to show you in the section on quadratic equations, quadratic functions is because we have this technology available, I don't have to show you every little piece of it, okay? There's a lot of stuff that when I started teaching 100 years ago, I had to show, we had to teach them how to do all this little stuff so that we'd understand what a quadratic equation, what a parabola and all that looked like, and how do you graph it and how do you figure out stuff about it. Now, because of the calculators, there's a lot of that stuff that's not necessary to teach you anymore because the calculator can do it for you, okay? So I'm going to give you an idea right here of what you would do. Here's what we call a quadratic equation or a quadratic function. The function notation is f of x. We use that in place of y. So just think of f of x as being y. Here in a minute, we're fixing to graph it. And instead of saying there's the x-axis and there's the y-axis, we're just going to say that's the f of x-axis. And so f of x notation, function notation, is just an easy way to ask, for instance, if I had this function and I wanted to say, hey, what is y equal to when x is equal to 14? Well, then that means you put in a 14 and you work it out and you see what y comes out to be. Well, an easier notation is I would just say, hey, what's f of 14? If I just said f of 14, that means you put in the 14 in place of x and you figure out what it's equal to and all that. So again, that's called function notation. And so this is the instructions here. Let me just show you the general idea. If you're ever trying to graph something, and you don't have any idea what the graph of it looks like. I don't know what the graph, I don't know if it's a circle or a parabola or something else, a line. You don't have any idea what it looks like. You can always just put in numbers for x and evaluate, figure out what y is, and then plot those points on the graph, and then get an idea, see what it looks like, see which way it's going, okay? So, for example, right here, let's think of some numbers to put in for x and figure out what we get. So like if we let x be equal to 2, if x is equal to 2, then you put in a 2 for x and you get 2 squared, all right? So the same thing we're finding is like f of 2, right? That's how we say it. So you just put in a 2 everywhere you see x. So if I want to, okay, again, I'm looking for some points on the graph of this thing. I put in x is equal to 2. By finding f of 2, I put a 2 in everywhere I see x. And so I get, instead of x squared, I get 2 squared. Instead of 8x, I get 8 times 2. All right, and I just work all this out. So remember, order of operations, do the powers and roots from left to right, then multiplication and division from left to right, and then addition and subtraction from left to right. So 2 squared is 4, 4 times 2 is 8. So this is 8 minus 16 plus 9, because 8 times 2 is 16. 8 minus 16 is negative 8, plus 9 is 1. All right, so when x is equal to 2, y is equal to 1, or you might say f of x is equal to 1. Hey, remember how to graph points? X coordinate, Y coordinate, abscissa ordinate, all that. This tells you how far to go left or right. This tells you how far to go up or down. So the point 2, 1 would be right there. So there's a point on the graph, all right? So let's find another. Let's find the easiest one. All right, watch this. One thing that I might ask you to find is, the y-intercept, or the f of x intercept, okay? When we're looking for the y-intercept, the basic thing, when we've done this before, you say, okay, if you're looking for y-intercept, let x be 0. Remember I showed you that a long time ago? Anytime you want the y-intercept, let x be equal to 0. So let x be equal to 0 and see what you get. F of 0 is equal to 2 times 0 squared minus 8 times 0 plus 9. And this will be your favorite one because 0 squared is 0 times 2 is 0, 8 times 0 is 0, so 0 minus 0 is 0 plus 9. All right, so what happens is when you put in 0, you just get whatever's sitting out there. So just like, remember y equals mx plus b for lines, that b was always a y-intercept because whenever you put in a 0 for x, the mx goes away and all you have is a b. Same thing here. All this stuff with the x in it goes away when you let x be equal to 0. And so that's just going to be whatever the y-intercept right there. So 0, 9. So let's think of some other numbers to put in, like if x is equal to 1, we find f of 1. Let me do this kind of quickly, kind of in my head right here, right? Put in a 1 here, you get 1 squared is 1 times 2 is 2. 2 minus 8 is negative 6, plus 9 is 3. How about a negative? Let's put in a negative just because, you know, there's going to be stuff over there too. By the way, 0, 9 goes what? Way up here, right? And 1, 3 would go right up in here. All right? And put in a negative 2. If we put in a negative 2, see if we can do this in our heads. Negative 2 squared is 4. 4 times 2 is 8. So that's 8 minus, okay, watch this. Negative 8 times negative 2 is 16. So 8 plus 16. 8 plus 16 is like 24, plus 9 is 33. Who didn't know it'd go this high, right? So it's way up here like that. So when I put in a negative 2, I get something way up there. 33. All right, so let's see what's over on this side of the graph over here. Let's put some numbers in over there. Like, let's keep going to let x be equal to 4. If you put in a 4, you get 4 squared is 16 times 2 is 32. 32 minus 8 times 4 is 32. Plus 9 is 9. So I got negative 32. I think I got 32 minus 32 is 0 plus 9. So 4, 9. So the point 4, 9 would be up here like this. Yeah, I had 0, 9 over there, so it's even with that. All right. So now I'm starting to see what this thing is like. It's a parabola, what we call a parabola. It's a curved figure like that, where it's way up over there and way up over there, and it comes down here, and it's coming down to a turning point somewhere in there. And it looks like the turning point might be around 2, 1. We can get a better idea of that by doing some more math here. All right, so let me show you what I need you to be able to find out today, and hopefully your calculator will have downloaded pretty quickly, and we can get up on there and we can show you the same thing on there. Okay, so finding the axis of symmetry. All right, there's something called an axis of symmetry. Symmetry is maybe 1 in, maybe 2. That looks pretty good. I'm not sure. Might be one more in. Axis of symmetry. Symmetry means it looks the same on both sides. Like if you cut the human body, you know, if you cut it down here, down by this axis, it's amazing how close this side looks to this side. We're symmetric. Also, let's see, if you cut the human body like this, we don't look the same, right? If you cut it by this axis, we're completely different down there than we are up here. If you cut the human body like this, and this axis right here, we're completely different in the front than in back, okay? So the only way that the human body is symmetric is like this, all right? There are some animals that are symmetric in 2 different directions, right? In fact, maybe starfish or something like that might be more than 2. I don't know, I have to think about it. But anyway, symmetry. It looks the same on this side as it is on this side. The axis of symmetry means there's some line that divides this thing where it looks exactly the same on one side or so you could fold the parabola and it would come over, all right? To find the axis of symmetry, it falls into this formula. Negative b over 2a, all right? What's a and b? All right, A and B, let's go back to then the general form for the equation of a parabola, f of x, is equal to ax squared, all right, plus bx plus c. All right, so with ax squared plus bx plus c, that means a is the coefficient on the x squared, b is the coefficient on x, and c is a constant out there. So when I ask for x is equal to negative b over 2a, you want what's the number over times the x, and then over the 2 times the number on the x squared, okay? So back to our problem right here, if I wanted to find the axis of symmetry of this, a is equal to 2, b is equal to negative 8, and c is equal to 9, all right? So when I look for x is equal to negative b over 2a, I'd say x is equal to the negative of negative 8, so watch out for negative signs like always, over 2 times 2. So negative 8 is 8, positive 8. 8 over 2 times 2, which is 4. All right. So moral of the story is the axis of symmetry is the line x is equal to 2. X is equal to 2. All right, so that does go right through this point right here. So we had our turning point right there. So that means that this parabola is going to look exactly the same on this side as it does on that side. The other interesting thing about the parabola is the vertex. The vertex has to go through the axis of symmetry. It has to be on the axis of symmetry. So if I know that the axis of symmetry here is the line x is equal to 2, well then the vertex has to be on that line somewhere. So if you want to find the vertex is just a point. It's the turning point. The vertex will be the turning point of the parabola. So if you want to find that turning point, you start with x is equal to 2. In other words, you know that x has to be equal to 2 because it's on the axis of symmetry, and we've already found a while ago f of 2 is equal to 1. So the vertex of this fella is going to be 2, 1. So this point 2, 1 is the vertex. All right. So that tells me enough about the graph to draw a good graph of it now. It comes through here like this. Wasn't drawing anyway, so anyway, it goes way up like that, there we go, like that, and coming through like this. There we go. Alright, so ideally, you know, those points would be on it there, close enough. But that's what a parabola looks like. A parabola comes way up over here, way up over there, down here it comes to a minimum point. The minimum is the vertex right there. And so to be able to graph it, you need to be able to use the table, you need to be able to find the axis of symmetry and the vertex. Okay, tell you what I need to do. I need to stop there and do a different video because if I do them too long, it doesn't work.